A $13 billion warship just got humiliated by a $2,000 drone. And nobody's talking about what that actually means. The USS Dwight D. Eisenhower is one of the most powerful machines ever built by human hands. Nuclear-powered, nearly 100,000 tons of steel, 70 fighter jets on deck, 5,000 sailors inside. It can project American military power anywhere on Earth within days. And in November 2023, Iranian-backed rebels in sandals and pickup trucks started making it look vulnerable. Wave after wave of cheap commercial drones, the kind you can order online, started hitting US warships in the Red Sea. The Navy responded the only way it could, firing interceptor missiles worth millions of dollars to knock down targets that cost less than a used car. By the time the dust settled, America had spent over $200 million in defensive fire, stopping attacks that probably cost the Houthis a few $100,000 total. And somewhere in Beijing, military planners were taking very careful notes. Because what just played out in the Red Sea wasn't just an embarrassing expense report. It was a preview, a stress test of the most expensive military asset on Earth against the cheapest possible threat. And the results raised a question that the Pentagon still doesn't have a clean answer to. What happens when it's not dozens of drones, but 1,000, all attacking at once?
Start with the numbers, because the numbers are where this story gets genuinely alarming. A single SM-2 interceptor missile, the standard weapon American destroyers use to shoot down incoming threats, costs $2.1 million. The SM-6, which handles more advanced targets, runs $3.9 million per shot. These are the weapons currently standing between a US carrier strike group and anything coming at it from the air. Now look at what they're shooting down. A commercial DJI Mavic Pro drone costs around $2,000. No special order, no black market connection required. Walk into an electronics store, hand over a credit card, walk out with a weapon system. Strap a small explosive charge to the frame, pre-program a GPS route, and you've just created something that forces the US Navy to spend 2,000 times more destroying it than it cost to build. From November 2023 through January 2025, American warships in the Red Sea burned through 120 SM-2 missiles and 80 SM-6s fighting off Houthi attacks. That's over $500 million in defensive fire. The Houthis' entire drone campaign probably cost a few $1 million in total. They didn't need to sink a single ship. They just needed to keep the economic bleeding going. And here's the part that makes Pentagon budget analysts sweat at night. Even the most heavily armed American destroyer carries fewer than 100 interceptor missiles total. That's it. That's the magazine. Once those are gone, the ship is essentially defenseless against air threats until it can resupply.
Here's where most people misunderstand the threat. They picture 1,000 drones flying in a cloud toward a ship, and they think the problem is just volume. Shoot enough of them down, and you win. But that's not how modern drone swarms work. And the difference between what most people imagine and what's actually being developed is the difference between a nuisance and an existential threat. A true drone swarm isn't just a lot of drones flying in the same direction. It's a distributed, autonomous system, making collective decisions in real time. The drones communicate with each other constantly. They divide tasks between themselves. When one gets shot down, the others automatically redistribute its assignment among themselves. They adapt to countermeasures on the fly. They don't panic, don't hesitate, don't need a human in the loop to adjust their strategy mid-attack. The Naval Postgraduate School in Monterey, California was already flying 50 fully autonomous drones simultaneously back in 2016. Coordinated, communicating, adapting, nearly a decade ago on a research budget. The technology has advanced exponentially since then, and it hasn't just been advancing in American laboratories. In 2024, China unveiled something that should have gotten far more Western media coverage than it did: the Xiao drone mothership, a massive unmanned aircraft capable of carrying and launching 100 smaller attack drones mid-flight. It has a range of 7,000 kilometers and cruises at 560 miles per hour. Now imagine not one of those platforms, but several, operating in coordination beyond radar reach. The carrier group doesn't detect the motherships. It doesn't get a warning. By the time the first radar ping comes back with something suspicious, hundreds of attack drones are already inbound and closing fast. That's not a hypothetical. That's a capability that exists right now.
And China isn't being subtle about how they intend to use it. Chinese military journals published in 2022, open source, publicly available, not classified intelligence, laid out their exact strategic framework for attacking American aircraft carriers. It reads less like military theory and more like a step-by-step operational checklist. And it's been refined continuously since then, using live combat data from Ukraine, where both sides have been running the largest real-world drone warfare experiment in history. The framework works in 4 waves, each one designed to set up the next. Wave 1 is all about waste. Cheap decoy drones flood the carrier group's airspace, forcing the warships to burn through their expensive interceptor missiles, shooting down targets that have no weapons and no real mission beyond existing. The carrier group's magazine starts draining before the real attack even begins. Wave 2 hits while the defenders are still processing Wave 1. Electronic warfare drones move in, jamming communications between ships, disrupting radar systems, cutting the information links that allow a carrier strike group to function as a coordinated unit. Suddenly, the ships can't talk to each other clearly. Commands get garbled. The tactical picture starts breaking down. Wave 3 goes.
An aircraft carrier is designed to look invincible. That's part of its strategic value. The psychological weight of 100,000 tons of nuclear-powered steel showing up off your coastline. But the illusion of invincibility has a price. And that price is that when the vulnerabilities do exist, they're not obvious until someone starts thinking creatively about how to exploit them. The critical insight is this: a carrier doesn't need to sink to lose. It just needs to be unable to operate. Mission killed in military terminology, forced to withdraw. And mission killing a carrier is dramatically easier than sinking one. The flight deck is the most exposed target and the most valuable one. 4.5 acres of flight operations, aircraft staged for launch, fuel lines running everywhere, weapons being loaded, crew members moving in every direction. A coordinated strike of just a dozen small drones hitting that space simultaneously doesn't need to destroy the ship. It just needs to create enough chaos and damage that nothing can safely take off or land. The carrier's entire reason for existing, projecting air power, stops immediately. The ship is still floating. It just can't do its job. Then there are the sensors. Modern warships are covered in antennas and radar arrays. And here's the design problem that can't be engineered away. These systems need unobstructed sightlines to function. They can't be armored without destroying their effectiveness. A drone carrying 5 pounds of explosives can destroy a multi-million-dollar phased array radar panel in a fraction of a second. Lose enough of those panels, and the ship can no longer see what's around it, can no longer track incoming threats, can no longer coordinate its defenses. Even the last line of defense has problems. The close-in weapon system, the CIWS, the rapid-fire cannon that's supposed to be the final barrier between the ship and anything that gets through, was engineered for a different era. It was built to handle fast-moving anti-ship missiles traveling at near supersonic speeds. Slow-moving commercial drones approaching from 10 different directions simultaneously fall outside the engagement envelope it was designed for. A 2020 analysis published in the Naval Institute Proceedings put the problem plainly. Warship radar systems are calibrated for traditional threats: fast jets at altitude, high-speed cruise missiles at low altitude. Small drones flying slow and low generate a fundamentally different radar signature, one that's harder to detect, harder to track, and harder to engage with weapons that weren't built for them.
Here's something the doom and gloom framing usually leaves out. The US military has known this was coming for years, and they haven't been sitting still. The USS Gerald R. Ford deployed in 2025, carrying 2 systems that didn't exist on American warships 5 years ago, both designed specifically to address the swarm threat. Raytheon's Coyote Interceptor is a small turbojet-powered drone that launches from deck canisters, flies out to meet incoming threats, and destroys them with a fragmentation warhead. The key innovation is reusability. Certain configurations can return to the ship after a mission, refuel, and launch again. That directly attacks the magazine depth problem. Instead of burning through expensive missiles that are gone once fired, you're operating a system that can keep going. Northrop's Roadrunner M takes a similar airframe concept and adds something more significant: autonomous AI-driven target recognition. The system can loiter in the airspace around the carrier, identify incoming threats without human input, and engage at machine speed, faster than any human operator could process the same information and make the same decision. Both systems have already seen real combat with Army and Special Operations Forces. They're not prototypes, they're proven. But they're also not magic. Each interceptor still costs tens of thousands of dollars, still requires a logistics chain, and is still being evaluated in real operational conditions aboard the Ford. Directed energy weapons represent the more radical solution. High-powered lasers can theoretically shoot down drones for a cost measured in electricity, cents or dollars per engagement once the system exists, compared to millions per missile. The Navy has been developing this capability for over a decade. The first destroyer equipped with a functioning combat laser went operational in 2021. But scaling that technology across an entire fleet takes time, and atmospheric conditions, humidity, rain, fog, still limit laser effectiveness in ways that missiles don't face. The Pentagon's Replicator initiative is the most ambitious response, deploying thousands of autonomous American defensive drones by 2026, specifically to counter swarm attacks. The concept is elegant: fight swarms with swarms. American defensive drones intercept attacking drones before they reach the carrier line. No missiles required. But building that capability means solving the exact same artificial intelligence and coordination challenges that make enemy swarms dangerous in the first place, and solving them first.
We don't have to theorize about how carriers and their escort ships handle sustained drone pressure. We have real data now, and it's more sobering than most people realize. Since November 2023, U.S. Navy ships have fought off nearly 400 separate attacks in the Red Sea and Gulf of Aden. That's not a statistic. That's the highest sustained combat tempo American naval forces have experienced since the Second World War. Sailors running to battle stations, weapon systems firing in anger, equipment being pushed hard every single day in a way that peacetime operations never replicate. The performance has been genuinely impressive. The Navy has stopped the overwhelming majority of attacks. Ships have come through, but the cumulative cost is real. Interceptor missile stockpiles have been depleted significantly. Maintenance schedules have been compressed. Crews are operating under a level of sustained stress that simply doesn't exist outside of actual combat. And critically, the Houthis are not a sophisticated military power. They don't have China's manufacturing base, China's engineering talent, or China's defense budget. China produces more drones in a single month than the Houthis could field across their entire campaign. General Eric Kurilla, the head of U.S. Central Command, told Congress in March 2024 exactly what he was worried about. Cheap drones ranked among the top threats facing American forces. Swarms ranked as an even more severe concern. His recommendation wasn't subtle. Accelerate high-powered microwave weapons and layered defense systems to the fleet immediately, not on a decade-long procurement time. Get them there now. The combat experience in the Red Sea has been genuinely invaluable in one sense. The Navy is learning things in live fire that no exercise could teach. New tactics are being developed in real time. Crew training is being reshaped by actual engagement. The aircraft carrier isn't going away. Anyone who tells you that hasn't looked at the actual capability these platforms provide, or the timeline and cost required to replace that capability with something else. But the carrier of 2035 is going to look very different from the carrier of 2015, and the difference is going to be measured in drones. 5 major defense companies currently hold contracts to develop what the Navy calls collaborative combat aircraft, autonomous wingman drones designed to operate alongside manned fighters from carrier decks. General Atomics, Boeing, Anduril, Northrop Grumman, and Lockheed Martin are all in the competition. The mission profile is exactly what the swarm threat demands. Fly ahead of the strike group to screen for incoming threats, intercept attacking drones before they reach the ship, and accept risks that no one would accept with a human pilot in the cockpit. The Navy wants these operational before 2030. The MQ-25 Stingray autonomous tanker drone is already further along. It successfully refueled F-18s, F-35s, and E-2 Hawkeyes in flight tests in 2021. First operational deployment is scheduled for 2026. On the surface, that sounds like a logistics improvement. Free up fighter aircraft from tanker duty, extend the air wing's combat range, but the deeper significance is what it proves. The carrier can operate fully autonomous systems from its deck at scale. The infrastructure, the procedures, the crew training, it all exists. Building on that foundation to field combat-capable autonomous systems becomes a much shorter step. Longer term, the concepts being explored in naval war colleges and defense research programs are more radical still. Smaller, more distributed carrier designs that spread risk across multiple hulls rather than concentrating it in one vessel. Optionally manned ships that can reduce crew size dramatically during high-threat operations or operate entirely autonomously when the risk to human life becomes unacceptable. And fully autonomous swarm versus swarm engagements where American defensive drones coordinate in real time to intercept attacking swarms before any human commander could process what's happening, let alone respond to it. The technology race is moving. China, Russia, Iran, and Turkey are all developing autonomous swarm capabilities at varying levels of sophistication. Some of them are ahead of the United States in specific technical areas. The trajectory is clear, regardless of who's leading at any given moment. Autonomous swarms will define 21st century naval warfare the same way carrier aviation defined the 20th century. The question stopped being whether a long time ago. Now it's about timing, and about whether the right investments are being made fast enough.
Will 1,000 drone swarms sink a U.S. aircraft carrier? Almost certainly not. The ship's hull compartmentalization, damage control systems, and sheer structural mass makes sinking genuinely difficult, even under severe attack. But sinking was never really the point. Mission kill the carrier, ground the flight deck, destroy enough radar arrays that the ship can't see what's around it, force it to withdraw from the combat zone for repairs and resupply. The carrier stops projecting power without going to the bottom. And from a strategic standpoint, that's a win for whoever launched the attack. That's the realistic threat. And that's specifically what the Pentagon is working to prevent. The men and women serving aboard American carriers are operating at a level of professional skill that doesn't get nearly enough credit in these conversations. They're training constantly for scenarios that most people will never think about. They're doing it with equipment that was designed for a threat environment that shifted dramatically beneath their feet. And the pace of adaptation happening right now in research labs, in acquisition programs, in real combat experience in the Red Sea is genuinely impressive. But impressive isn't the same as sufficient. The window between when a threat becomes theoretically possible and when it becomes operationally deployed is getting shorter every year. The drone revolution in warfare isn't a future problem, it's a present one. And what happens in the next 5 years, in laboratories, in shipyards, in congressional budget hearings, will determine whether the most powerful naval force in history adapts fast enough to stay that way.